In Algebra 1-2, you learn about quadratic equations and how they create the shapes of a parabola. And today we're going to talk about those quadratic equations and how can we rewrite an equation that's in standard form. So please write down example 1. We're going to start off with an Algebra 1-2 question. And we're going to talk about how we can take an equation that's in standard form and rewrite it in vertex form. Vertex form will be the easiest way for us to identify the vertex. It'll be the easiest way for us to graph a quadratic equation. And so I'm going to go through this slowly. Make sure all your cell phones are put away. Make sure your earbuds are put away as well. So this is standard form. I have an A, a B, and a C. I'm going to start by taking the C value and I'm going to move it to the opposite side. So because it is a negative, I'm going to add it using the opposite operation. Now I have y plus 9 equals 1x squared plus 16x plus some unknown number. I want to achieve a number here so that I can easily factor in a specific form. And so there's a shortcut method to doing that. Now I will say that it is most easy to rewrite this in vertex form when the number out front is a 1. And that's what you learn in Algebra 1-2, or you should have learned in Algebra 1-2. In Algebra 3-4 and in pre-calculus, we often change this number to make it a negative and to make it a number that's different than a 1. So we need to figure out what is this missing value in order for us to nicely factor this into a perfect binomial. And so to do that, what we're going to do is, here's the shortcut. I'm going to take whatever is this b value, it's the value that is stuck with the x, I'm going to write it down with the sign in front. So it's a plus 16. I'm always going to divide it by 2 and I'm always going to square it. So if that was a negative 16, I'd write down negative 16 divided by 2. Always divided by 2 and always squared. Whatever we get goes into this position. So 16 divided by 2, 16 divided by 2 is 8, and 8 squared is 64. So I'm going to rewrite this. I have y plus 9, and now I've filled in that spot, and that number is 64. How did I get that? 16 divided by 2 is 8, 8 squared, 8 times 8 is 64. This equal sign means that the left and the right side must always be equivalent in value. I just randomly added a 64 to the right. In order for me to keep the left side and the right side balanced or equal, if I randomly added 64 to the right, I must also add 64 to the left to keep it balanced. Now on the left-hand side, I have y plus 9 plus 64 is 73. And now here's the part that's a shortcut. I'm going to do it the long way. You're welcome just to watch. If I asked you to come off to the side and to factor this, you'd say to yourself, okay, what multiplies to get 64 and combines to get a positive 16? And you'd rack your brain, you're like, oh, 8 and 8. 8 plus 8 multiply to equal 64, and they are going to add to give you 16. So this would be x plus 8 and x plus 8. Oh, a better way to write that would be x plus 8 squared. So the shortcut right here is, once we had this trinomial, here's the really shortcut. We put our parentheses down, and we always go up to whatever was in this space, and I reduce it. Positive 16 divided by 2 is positive 8. Notice how I've taken this exact same thing, I've reduced it. 16 divided by 2 is 8. There's the square, and I've put an x in front. So instead of coming off to the side and having to factor this and think really hard, I'm able to drop this down and use this as a guide to coming up with a way that we can quickly factor this trinomial. Okay, so our whole goal is to take what was in standard form, and we want to write an equivalent quadratic equation, but to put it in vertex form. Now, to rewrite this, I need y equals some quantity, so I'm going to move the 73 back to the right-hand side, and now I have an equation. If I graphed this equation and I graphed this equation on the same Cartesian plane, you would see that they're the exact same parabola. They come from the same quadratic equation, just in different forms. What does this give us? This easily tells us what the vertex is as a reminder. So the vertex of this, if you're wondering what is the vertex, remember it is our lowest point or it's our highest point. It also splits our parabola so that we have 2 equal halves because it is symmetrical. The vertex can easily be identified. In this case, the vertex is negative 8 and negative 73. So on the graph, -8, -73 would be where I can find the vertex. Now, a nice thing about standard form is standard form we can easily identify the y-intercept. So the y-intercept for this problem is going to be 0, -9. Example number 2 is just slightly different than example number 1, and that's because notice that the leading coefficient, or we call this the a value, in this case it is not a 1. So it takes just a little more work, and we got to be cognitive of this number as we work through this problem. So the first thing I'm going to do is just like our previous example. Notice in our previous example, I took what was called the c value, this constant, and I moved it to the other side. Opposite of subtracting 9 was adding 9. We're going to do the same thing here. So opposite of adding 20 is going to be subtracting 20. But now I have to account for this value that's in front of the x squared that's not a 1. Whenever it's not a positive 1, we've got to take an extra step here. So what we have to do is we have to factor out that value. So I'd like everybody to put a 3 and then parentheses behind it. When I factor out a 3, this is the thought process. 3 divided by 3 is 1. Bring down the x squared. -12 divided by 3 is -4. Bring down the x. So notice how this looks very similar to example number 1. Very similar to example 1, but the key difference here is that there is a value out front that we need to be aware of later on. So I'm going to do the same steps I did in example 1. I'm going to figure out what is that b value. That's the value that's stuck with the x. I'm going to take that value, I'm going to divide it by 2 always, and square it. I do have to consider whatever symbol is in front of that value. So it's not just a 4, it's a -4 divided by 2 and then squaring it. -4 divided by 2 is -2, and -2 times -2 is +4. So I'm going to come up to this position and I'm going to put a +4. In example number 1, remember I explained that we need to keep both the left and the right side balanced or equal to each other. I just added a value of 64 to the right, so I had to add a value of 64 to the left. But in this case, even though I put down a 4, I didn't add a value of 4 to the right. I added a value of 12 because we have a value up front. So I added a value of 12 to the right-hand side. So because I added a value of 12 to the right, I must also add a value of 12 to the left to keep the left and the right balanced. -20 and +12 combine to give us a -8. And now here's the shortcut step that I explained in example number 1. I'm going to use this to guide my shortcut. I'm going to write the parentheses down, a square's on the outside. I'm going to slip an x in front of that parenthesis, and now the value and the sign that comes behind the x goes right back here. -4 divided by 2 is -2. My entire goal right now is to take a quadratic equation that's in standard form, and we're going to rewrite it in vertex form. So I'm going to add 8 to the right-hand side so that y is by itself. I have 3 times the quantity x minus 2, quantity squared, plus 8. If I graph this equation, it'd be the same thing as this original equation that was in standard form. This is vertex form, this is standard form. Let's identify the vertex. The vertex of this parabola occurs at +2 and +8. This lies to us, this tells us the truth. The y-intercept of this quadratic equation occurs at 0, 20. This is example number 3, and it's going to mimic example number 2. Why is that? I'm going to put an arrow above the 5 right away. Just, it gives me an idea that I need to identify that I'm going to have to factor out the value in front. Now, when do we factor out the value in front of the leading coefficient? Or, excuse me, in front of the x squared in this case? We do that whenever this value is anything different than +1 when we are using the completing the square method to rewrite in vertex form. Let's move this c value over to the left-hand side. So I have y subtract 12 equals, now I could write this out 5x squared plus 10x plus some unknown c value. That's true. Or maybe I want to combine those steps to do one less step, And after this part is done, I can simply right away factor out the 5. So I'm factoring out the 5. Now how do I get what goes inside? 5 divided by 5 is 1. Drop down the x squared. Positive 10 divided by 5 is positive 2. Drop down the x. And then I have this unknown value. So instead of writing down this step, you are welcome to drop down to this part where you factor out that 5 right away. How do I figure out this unknown value? I'm looking at this trinomial that's in parentheses. I'm taking the b value. Notice not just a 2, it's a positive 2. I'm dividing it by 2 and I'm squaring it. So 2 divided by 2 is 1, and 1 squared is 1. 1 times 1 is 1. Okay, I would like you in front of me to give me a thumbs up or a thumbs down so I understand what you are getting about this problem. I just added 1 to the right. If you agree with this statement, do I need to put a positive 1 on the left? Give me a thumbs up. If you disagree, put a thumbs down. I just added 1 to the right, so I should put a plus 1 on the left. That's a common mistake, but I didn't just add 1 to the right. What did I actually just add to the right? I added a 5 because 5 times 1 is 5. I added a value of 5 even though there's a 1 there. Remember, this number up front is going to be multiplied by everything inside. So on the left-hand side, to keep the left and the right balance, I'm going to do a plus 5. Negative 12 and positive 5 gives us a negative 7. Here's the 5 out front. And remember, here's the shortcut. I'm going to use this to guide me through the shortcut. I'm going to drop down an x, and then I'm going to do the math. Positive 2 divided by 2 is a positive 1. And I have one last step to write this in the correct vertex form. I'm going to add 7 to the right-hand side. Y equals 5 times x plus 1 quantity squared plus 7. Let's identify the vertex. The vertex for this problem is negative 1, positive 7. It lies to us and it tells us the truth. Up here we can identify the y-intercept as 0, 12. Okay, working through this example, I'm going to start by moving the c to the opposite side. So I'm going to subtract 17 to the left-hand side. And then right away, I'm going to go through and I'm going to factor out the value that is different than a positive 1. Anytime the leading coefficient of this quadratic equation is different than positive 1, I need to factor it out. How do I determine what goes inside? Negative 2 divided by negative 2 is 1. Bring down the x squared. Positive 12 divided by negative 2 is negative 6. Bring down the x, and we have this missing piece that we're going to fill in. This is the trinomial that I'm focused on. And I'm going to take the b value, including the sign, divide it by 2 and square it. So negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. But I did not just add positive 9 to the right. In fact, I added a negative 18. To keep the left and the right balanced or equal, if I added a negative 18 to the left, to the right, I must add a negative 18 to the left as well. So the right and the left both received a negative 18. Combining the like terms, I have negative 35 on the left-hand side. And now what goes inside of here? I'm going to use this. So in order to factor this, I'm going to drop down the x. Negative 6 divided by 2 is negative 3. This is a really common thing students forget, is this square. And that's going to make a difference when we start to solve this. So right now we're just writing in vertex form. We're going to increase the difficulty of writing in vertex form tomorrow. And then we're going to work on solving when they are in vertex form. I'm going to add 35 to the right-hand side. And I have y equals negative 2, x minus 3 quantity squared, plus 35. If I graph this equation and the original, this is standard form, this is vertex form, they would be the same. Notice up here I have a y-intercept of 0, 17, and down here I have a vertex. It lies to me and it tells me the truth.